so imagine you're going on a 2-day hike up a one-peaked mountain. And in your backpack, you have 50 red flags. On your journey as you travel, you're going to set down these flags at different points on the mountain. So you may start at the foot and then put one at the top, and then as you go along in different positions all over this mountain. So what you have essentially now created is a directional data set. Now, suppose your friend calls you and tells you he wants to do the same hike, but he wants to camp right in the middle of the incline. How would you determine from these red flag points that you now have, the directions, how would you determine such a midpoint? Now, in directional statistics, we have means to determine such a point. What we would like to firstly do is to take the points that we now have on our mountain over here and project it onto a ball. On this ball, we will now take into consideration the distances between the points that you have collected. Mainly, we will focus on the bottom or the foot of the mountain and the top of the mountain. So the first measure, or the existing model that we can use for this, is the von Mises-Fisher distribution. Now, this distribution uses a straight line distance to connect the 2 points. This is called the Euclidean distance. The problem with this is that taking a straight line is essentially cutting through this ball, not taking into account the surface points that we're actually considering. So, counterintuitively, you end up looking at all the points on this ball to be reasonable midpoints that you might find. So this does not make sense at all. So the new model introduced, the spherical normal model, makes use of a distance measure that takes into account the curvature of the ball, the curvature of the distance between these 2 points. This is called the geodesic distance. Now, in doing this, calculating the distance by taking into account the curvature, we end up with a belt of plausible values that might mean or might indicate our midpoints. And thinking of an aerial view of a mountain, this makes sense. You have the foot of the mountain and you have the top. So somewhere in between here, you have a midpoint. But since the journey that you traveled is not the only point to get to, or the only way to get to the top, you end up with a ring of values around this peak that might be plausible. So it's a more effective and more usable way for accurately measuring that midpoint. So what we would like to do in the future, what I like to do in my research, is to expand this single mountain that we currently have to a whole mountain range with many peaks and valleys petering out to the left and to the right, and then to again project it to the ball and see how it acts on the ball. Can we see concentrations of data points and so forth? So essentially, we're trying to pick the perfect camping spot every single time.